Today, society faces a problem that could have easily been prevented, but still remains as one of the most prominent issues in the world.
This issue affects all globally, but through this project, a change will be conducted.
Today, researcher Gabriel and Robin H. Pinto, Maria Stephanie Lane D. Jeciel, and I, Franz Dylan H. Blanco, are here to discuss our project, NVI-ROVER.
Garbage is the main problem here in the Philippines. In 2023, the Philippines recorded more than 60,600 tons of garbage each day, with the Calabarzon region producing the most waste in the country, followed by the National Capital Region.
In the year 2000, the Philippine Congress released the Philippine Ecological Solid Waste Management Act of 2000. Solid waste management is an essential environmental concern in the Philippines. Therefore, the local government was able to provide regulations for proper trash prevention and recycling measurement in order to reduce the amount of waste that spreads throughout the community.
Now, let's talk about the photoelectric sensor that the researcher will use to detect certain trashes around the city, according to the light emission which occurs by light beam to detect specific material. Photoelectric sensor technology is used to detect the light reflection of various objects including metal and non-metal like plastic, metal, and wood. Although there are various of limitations that photoelectric sensor contain, including possibility of limited sensing range due to the reflective of the target object, the potential of difficult installation method, and the risks of dust or other contaminating the lens over time.
The researcher used Arduino in order for the robot to function properly. Active control, methods, rapid accessibility, and simple fixing mechanism are some of the Arduino board's main advantages. Because of its easily accessible features, students mainly apply it for basic project development.
Here are the statements of the problem that will be answered later on. Firstly, why is a diffuse photoelectric sensor preferable for detecting different types of waste? Secondly, what is the maximum waste weight that the NVI-ROVER can hold before the container is full? And lastly, how can the NVI-ROVER help reduce plastic waste and promote segregation? In the making of this project, the researchers also need objectives such as expanding the application of robotics in waste management using the NVI-ROVER and encourage community participations in cleaning initiatives.
Now, moving on to the null hypothesis and alternative hypothesis, which states, in alternative hypothesis, there is a significant relationship between the NVI-ROVER and the type of waste it collects. There is a significant correlation between the photoelectric sensor and the end effector of the rover. There is a significant difference between the type of garbage and the photoelectric sensor used. And in null hypothesis, all of the hypotheses considered to be no significant correlation.
Littering is a major environmental and social problem in the Philippines. Improper waste segregation leads to population health risks and the spread of disease.
This particular study aims to minimize waste in public areas and promote cleanliness. By automating waste collector, the NVI-ROVER encourages individuals to take responsibility for their surroundings, leading to a healthier environment and improved public health.
This study focuses on testing the NVI-ROVER in controlled environments, such as sidewalks, roads, and other flat surfaces. However, there are certain limitations. It cannot operate effectively on sloped or rocky terrains. The collection capacity is limited by the size of the container, and the photoelectric sensors may have difficulty in detecting certain waste types.
The experimental design consists of two tests. One is to test the NVI-ROVER's flow on a certain amount and types of trash, the trash being the dependent variable and the flow being the independent variables.
The second is the control group to test by the traditional way with the researcher picking up and collecting trashes.
In conclusion, the research aimed to answer the paper's Chapter 1 question by proving the effectiveness of the NVI-ROVER for everyday cleaning. The prototype was built using cost-effective and readily available components, leading to a significant decrease in trash in Cavite City.
Here are the recommendations that the researcher would like to share so in the future the project can enhance and improve. That's all. Thank you for listening.